we do use a lot of creativity. Like in this example, where we wish to find the time period of a body which has been put into a tunnel. This is the first is a smooth tunnel which has been dug through the diameter of Earth. So this is Earth, and through this Earth passing through the center, somehow a tunnel has been dug. We are not bothered about what is the core, what is that is how the core is, there is lava is there or molten lava is there. We are not bothered. We are considering Earth as a body of uniform mass density, and from here passing through the center of mass, a tunnel has been dug and a body has been released from here. It may go from here to here and then start oscillating like this within this tunnel. We wish to find out what is the time period of this tunnel. Number one thing is, it doesn't matter whether the tunnel has been dug like this, in this direction or in this direction or in this direction. It is not that time period over here will be less and over here this will be more. This is all identical. It is something like asking, that is, if a person is over here and if a person is over here, why this person doesn't fall down? For Earth, it is all the things they are same. It's all identical. We are all pulled towards the center of the Earth and we experience the same feeling. This person experiences the same feeling as being experienced by this person. So whether the tunnel is like this or this or this, it doesn't matter. This tunnel is a smooth tunnel and passing through center. If we remember what we did in chapter gravitation, that is how the acceleration due to gravity changes, it varies as we go up from the surface of Earth and as we go down from the surface of Earth. We know that is, if we go x down from the surface of Earth, on the surface, if this is acceleration due to gravity is g, and if over here it is g dash, then over here g dash and g, they are related by the expression g dash equal g into 1 minus x upon r, where r stands for radius of Earth and which is almost equal to 6400 kilometer. This is not required over here. This will solve the purpose. So g dash equal g into 1 minus x upon r. If we see, that is when x becomes equal to r, when x becomes equal to r, so this by this is 1, 1 minus 1 is equal to 0, so g dash becomes equal to 0, that is acceleration becomes equal to 0. If you recollect, acceleration is equal to 0 at the mean position, that is restoring force is equal to 0 at the mean position. When x is equal to r, xm becomes equal to 0. So xm becomes equal to 0 in SHM at what position? That is at the mean position. So this stands for its mean position. So this is its mean position. Now we have some basic steps. First step is displace the body. Displace the body by small distance x or y. Let's say we displace that by y, right? And second is, if you remember, we find the restoring force. And third is, we put restoring force equal to mass into acceleration. And fourth is, we say that is acceleration is proportional to minus y. If this comes, then this is, we say this is SHM. And the last step is, we use the time period t is 2 pi y by a, which we had derived, right? So let's say from here, we have slightly displaced it by distance y. And from here to here is distance x, and let's say from here to here is y. So we say x plus y is equal to r, x plus y is equal to r. We have displaced, that is, this is the mean position. From here, we have displaced this body by distance y, and now it has reached over here. So this is going to be pulled back by Earth towards the center. So what is that force, or what is directly, if we have acceleration formula, why we have to get into the force? We directly have a formula, let's use it. We don't get into the derivation once again what we did in gravitation. So we have directly acceleration formula. So it comes over here, that is over here, the acceleration comes out to be, what is that formula is? That is g into 1 minus x upon r. That is the formula. Over here is x, but we are interested in proving that is acceleration is proportional to minus y. That is, acceleration is proportional to displacement from the mean position and it is opposite directed. If we can prove that, then certainly we can say that this is SHM, and if this is SHM, we can directly use this to find the time period, and if we do 1 by t, we can find the linear frequency of these oscillations or vibrations. So acceleration is g into 1 minus x upon r, x plus y is equal to r. We want something in y, not in x. So we replace x in terms of y. So this comes out to be g 1 minus, what is x? X is r minus y upon r. So a is equal to g 1 minus r by r plus y by r. This is equal to 1 only. So a is equal to g 1 minus 1 plus y by r. So this comes out to be A is equal to G into Y by R. So we see over here that is acceleration. This comes out to be, see, G is constant. G is constant. Don't say that is G is varying through this. That is fine. G is varying. But this, when we say G, this is at the surface only. This is 9.81 meter per second square. So this is not changing. Acceleration due to gravity, though it is changing, but when you put over here, the numerical value of G is going to be this one. So this is A is equal to G by R. G is constant, radius of earth is constant. So acceleration is proportional to Y. That is acceleration proportional to displacement. Also, that displacement has been in this direction and the acceleration is going to be, that is a pull. Earth is pulling it in this direction. The force is in this direction. So that's why acceleration is in this direction. So that's why they are opposite directed. So we can say acceleration is proportional to minus Y. If this is the case, then this is going to be SHM. So this is, we can say this is SHM. If this is SHM, we can say T is equal to 2 pi Y by A. We can conveniently use it. T is equal to 2 pi. What is Y by A? Y by A. So that is A. So that comes out to be R by G is equal to Y by A. So Y by A replaced by R by G. If you put the values as R as 640 kilometer into 10 to the power 3, we can do it meters, 9.81 meter per second square. This time period approximately comes out to be, I think, 84 minutes. So it takes 84 minutes to go from here to here, here to here, or let's say any motion, any periodic motion from here to once again to be in position. So it means if from here, if you release a ball, then this will go from here to here in almost half of this time, that is 42 minutes or so. It will reach from here to here, right? So if the tunnel is passing through the center, the time period is going to be T is equal to 2 pi under root R by G. What if this tunnel is not passing through the center, but is, let's say, it is passing like this? Then how to do it? Let's do this.